Hello ICSE warriors. Welcome back to my channel. My name is PrachiSharma and this channel is about learning chemistry for 10th grade ICSE. So if you're struggling with any topic in chemistry at the moment, you can reach out to me either on the Telegram channel or in the comment box below, or you can write me an email on psclassesicse@gmail.com. Now, today's session is on mind mapping. So we have a lot of series going on for mind map and we have covered about 5 chapters so far. So we are working on a consolidated way of revision of the chapter chemical bonding. Without wasting any time trying to keep the video as short as possible, let's get started with the mind map of chemical bonding. All right, students, let's get started with today's video. Now, this is what the mind map for today looks like. I have 2 pages for it. The first page is this one, then I have the next page, and then I have the last page, that is this chart, which is important for your reasoning questions. Now let's get started with the basic understanding of what is a bond and why is a bond formed. So atoms are you can say active in nature. That means if their valence electrons or if their valence shell is not satisfied, they will have a high tendency to try and chemically you can say attract or chemically act with another element, react with another element. For example, if an element has about 2 electrons in the valence shell, it would try and donate the 2 electrons to reach and to have the outermost octet complete and gain stability or the closest inert gas electronic configuration. So this is what the atom's ultimate target is. If for example, if we talk about inert gases, they are considered not reactive and they will not form bonds because their outermost octet is complete. Basics and simple understanding. Now when we talk about the outermost shell, we can have different scenarios. That means either your outermost shell will have 1 2 3 4 5 6 7 8 5 6 7 till 7, you can have different number of electrons in the valence shell. Depending on how many electrons you have in the valence shell, an atom will end up making different type of bonds. For example, you have 1, 2 and 3. What is easy for this element or this atom? This atom will try and donate electrons and be electronically stable. Okay, be chemically stable. If you have 5, 6 and 7, in that case it is easier for an atom to gain electrons, to gain the closest electronic configuration, that means to complete the outermost octet. So in that case it will gain electrons or it will share electrons. Okay, so when it is gaining electrons, now another thing is when you have 1 2 3 or the beginning of it, that is metals. When you have later section, that is non-metals. Metals can easily donate electrons to non-metals, and this kind of bond is known as electrovalent or ionic bond. Now when we talk about non-metals can form a molecule with itself or with another non-metal, that by sharing electrons, because they have 5 6 7, so they end up 1 1 sharing, 2 2 sharing, or 3 electrons sharing with a fellow atom. That kind of bond is known as covalent bond. The third type of bonding is when a lone pair exists with an atom, and that entire lone pair is shared with an atom. So that atom with which we are sharing it has a deficiency of a pair of electrons, and it's not offering anything for this particular bond. It is just sharing the lone pair from a different atom. Now let's start with the basic understanding of electrovalent compounds. So when we have metallic elements, they can easily lose electrons to non-metallic elements. The second is the metallic element will lose electron, therefore it will convert into cation and they are electropositive in nature. Non-metallic elements can gain electron, turn themselves into an ion, and they are electronegative in nature. I hope this much makes sense. Let's look at the definition for it. The chemical compounds formed as a result of the transfer of electrons from one atom of an element to another element is called ionic compound or electrovalent compound, Why do we call it ionic compound? Because you have two different ions being formed. One of them will become cation, the other one will become anion. And this is also known as electrovalent because one of them is electropositive in nature and another one is electronegative in nature. Let's move ahead. What is electrovalency? So the number of electrons that are donated or gained is the electrovalency of that particular bond. So the number of electrons that an atom of an element loses or gains to form an electrovalent bond is called electrovalency. Now, one common question that you can get is, why are ionic compounds considered stable compounds? So you understand that two different ions are present there. So it's not that just two different ions will be present. Sometimes same type of ions will be also present. So there is also a repulsive force, and to overcome the repulsive force, you have an electrostatic force of attraction between the oppositely charged ions, which is higher than the repulsive force. So you have two different types of forces working on it, which makes your compound stable in nature. So let's quickly read that, what you're supposed to write in the exams. So ionic compounds are formed by ions. We understand that. But there are also exists a repulsive force between ions of like charges. Since the electrostatic force of attraction between opposite charges is much higher, it makes the ionic compounds stable. I hope that makes sense. Let's move ahead on electrovalent part 3 and electron dot structure. All the electron dot structures are important for you, so make sure that you understand and practice how to make them. So let's start with the first one, NaCl. So make Na, 1 electron on the outermost shell, plus chlorine with 7 electrons, and you're getting Na plus chlorine minus. Okay, because your Na will donate 1 electron to chlorine, so you get positive ion and a negative ion. Let's move to MgCl2. So you have 1 Mg with 2 valence electrons. So you'll be using 2 chlorines because they have 7 each, and that gives you Mg2 plus chlorine 2 minus. Let's move ahead to the next one, that is CaO. So you have calcium with 2 electrons in the outermost shell, oxygen with a deficiency of 2 electrons in the outermost shell, and that will give you Ca2 plus and oxygen with 2 minus. Okay, one thing that you have to understand the difference here is that in the previous case you were using 2 Cls, so you added 2 here in front of Cl. In this case there are 2 electrons going to the same atom, so you are getting oxygen with a power of 2 minus. So make sure that you pay attention on these minute details where I see maximum mistakes from the students. Let's move ahead to the next one. So electropositive atom will undergo oxidation, electronegative atom will undergo reduction. Oxidation and reduction happen simultaneously because one of them will donate electron, the other one will gain electron. So it is happening simultaneously. Therefore, it is also known as redox reaction. So oxidation and reduction happen simultaneously because the electrons lost by the reducing agent must be gained by the oxidizing agent. So we have example here. Na combining with 2 chlorines will give you Na plus 2 Cl minus. Combining with chlorine molecule. So what will happen? This is oxidation happening, then you have reduction happening below. This reaction is redox reaction. Oxidizing agent means acceptor of electrons, reducing agent means donor of electrons. Make sure that these minute terms are very clear with you. If you have any issues, you can definitely reach out to me. Let's move ahead. We have covalent bonding. So covalent bonding is when we have a shared pair. So both of the atoms will contribute equal number of electrons to the sharing, and none of them will be higher, you can say, at privilege. For example, with coordinate bonds. So covalent bonding, both of them will have an equal share in this kind of bond. So let's look at the definition. The chemical bond that is formed between two combining atoms by mutual sharing of one or more pairs of electrons is called covalent bond, and the compounds formed are called covalent compounds. Now you can have 3 types here. You can have single covalent bond, double covalent bond or triple covalent bond. When you have single, that means one electron is coming from both the sides. Double means both of them are giving two electrons each. Then triple means three electrons from both the sides. So let's look at that example. So hydrogen molecule, chlorine molecule, HCl all have single covalent bonds. Carbon dioxide, oxygen, both of them have two covalent bonds. Then nitrogen and C2H4, you have a triple covalent bonds. Now, what is covalency? So, for example, electrovalency was the number of electrons being donated. Covalency is the number of electrons being shared. So, covalency of an atom is the number of its electrons taking part in the formation of shared pair. Covalency of hydrogen is 1, oxygen is 2, and nitrogen is 3. Okay, let's move ahead. Now, covalent bonds, part 2. So, in this case, I am talking about non-polar and polar covalent bonds. So, as we know that sometimes, for example, we talk about HCl. Okay, so Cl is a highly electronegative compound, and hydrogen is not. Hydrogen has low electronegativity. So, when we make a compound of sharing electron pair, chlorine has a tendency to attract the shared pair towards itself. When such a scenario happens, this type of bond is known as polar covalent bond, because one of them will gain slight negative charge. Chlorine will gain slight negative charge because it is pulling the electrons towards itself, and hydrogen will have a slight positive charge because it's low in electronegativity and it is able to electrons are going away from it. When we talk about non-polar covalent bonds, in this case, the best scenario is that both of the atoms are identical. That means chlorine. So both of them are identical, both of them have high electronegativity. Therefore, none of them can pull it towards itself. It will balance the shared pair between them and it will give it symmetry. And none of them will be able to pull it towards itself. Such type of bonds are known as non-polar covalent bonds. So let's look at these definitions. So first you have examples: chlorine, hydrogen, oxygen. Then you have HCl, water, and HF. Now, another question I get is, ma'am, is it possible to have a non-polar covalent bond with different kind of atoms? For example, this is chlorine molecule, so I understand both of them are chlorine, hydrogen, HH, oxygen, OO. But is it possible to have it with different ones? For example, CH4, methane, different ones. Yes, it is possible. In this case, the difference in electronegativity is very small between the atoms. So even if you have carbon and hydrogen, the difference in electronegativity is minute or it is low. Therefore, they are easily able to keep the shared pair between them and none of them is pulling it towards itself. So that, yes, that is possible. So let's see, non-polar covalent compounds. So covalent compounds are non-polar when shared pair of electrons are equally distributed between two atoms. Simple. Let's move to polar covalent compounds. So covalent compounds are polar when the shared pair of electrons are not at equal distance between the two atoms. One of them has more power and can pull the electron towards itself. So polar covalent compound. Let's move to the next one, covalent bond, and these are your electron dot structures for it. So the first is hydrogen molecule, H, giving you H, then you have shared pair, or you can also write it like this, H single dash H. Let's move to chlorine. This is non-polar again, Cl, which is giving you a single bond in between. Now N3 molecule, non-polar again. N has 3 electrons here, giving you 3 shared electrons or 3 bonds are shown. Then methane, non-polar. So C plus 1 electron of H in the bottom, and then you have 4 H's all around, which is giving you a compound like this. Let's move ahead to fifth one. This is carbon tetrachloride. So you have carbon in center and 4 chlorines on the side. So I have a plus sign all of them. That carbon is adding up with 4 of these chlorines, and that ends up giving you a compound like this. Then let's look at water. This is a polar covalent compound. So you have H, a single electron here, then you have oxygen showing all the valence electrons and a single one is here, and this will end up showing something like this. Then let's look at ammonia molecule, which is also polar. So you have H plus nitrogen, so you have 3 H's, then this gives you a compound like this. I think the first sheet is complete. Let's quickly move to the next one. We have a lot to cover and very less time left. So let's quickly move to coordinate bond. So coordinate bond is when you have a lone pair being shared with another atom which has a deficiency of 2 electrons. So let's look at the definition. The bond formed between two atoms by sharing a pair of electrons provided entirely by one of the combining atoms but shared by both of them is called coordinate bond, or it is also known as dative bond. What is the example here? The example is hydronium ion and ammonium ion. Both of the formation is very important. Alright students, let's move ahead to the second part. That is coordinate bond, and you have the structures, electron dot structures for both of them, hydronium ion and ammonium ion, highly important. So what is happening? So you have water molecule here, so you make the electron dot structure of water, combine one H ion. So when you have H ion and H is positive, that means H does not have any electron of its own, it's an ion, it has already donated an electron, so it is just H with no electrons at all, and it would need at least 2 electrons. So oxygen will provide the shared pair of electron to H, that is the lone pair. So if you look here, this is the lone pair that is being shared with hydrogen, and the arrow represents that it's a coordinate bond. The other bonds are regular bonds and the arrow one is always a coordinate bond. And then since hydrogen never offered an electron from itself, so it never got balanced out, and therefore you have a H plus on the top of it. Then ammonium ion, because it has a deficiency of one electron, I hope you understand that. Then you have ammonium ion, so ammonium ion, then you have NH3 and you have H plus, that means one H is being added to NH3, and H does not have any of its own electrons, so the shared pair or the lone pair is being shared with hydrogen and it has a positive charge on top. So both of the electron dot structures are highly important. The third is hydroxyl ion. So you have HOH, water molecule. In the water molecule, you are removing one H plus ion. So one H plus ion is being removed. That means it never left with an electron. The extra electron is still with oxygen itself. Therefore, the OH has a negative sign on the top. Let's move to the next one. On this side, I have written the conditions for the formation of ionic compounds, and then we have the conditions for each one of them. Let's quickly go through them. So conditions for the formation of ionic compound: low ionization potential, that means tendency to lose electrons; high electron affinity, that means a tendency to gain electrons; large electronegativity difference. When you have large electronegativity difference, the larger one can take electron easily, and the smaller electronegativity can easily donate an electron. So these conditions are important for ionic compounds. Let's move ahead to the next one. Conditions important for coordinate compound. So one of the two atoms must have at least one lone pair of electron. If you do not have a lone pair, you cannot form a coordinate compound. The second is another atom should be short of at least a pair of electron. So it should have a shortage of 2 electrons. That means the entire pair should be able to satisfy the other element or the other atom. So these two conditions are important for coordinate compound formation. Let's move to definitions. So chemical bond. What is a chemical bond? A chemical bond may be defined as the force of attraction between any two atoms in a molecule to attain stability. Okay, let's move to the next one. Now, what is a dipole molecule? When you have oppositely charged ions, they form a dipole molecule. Then you have same electronegativity. So when you have same electronegativity, in that case, that is a non-polar covalent compound. The electrons will stay in the center. Then slightly different, in that case, you will have a polar covalent compound. And much difference in electronegativity will give you an ionic compound. Okay. Now, let's move here. So you have conditions for the formation of covalent compound. So both atoms should have 4 or more electrons in the outermost shell. The second is both should be high in electronegativity. The third is both should have high electron affinity. That means both of them should have a high tendency to gain electrons. Only then they can easily share. Otherwise, one of them will end up donating and other one will end up accepting. Now, both should have high ionization energy. That means both of them should be able to share with each other. The last one is the electronegativity difference between the combining atoms should either be 0 or negligible. So these are the conditions for your formation of covalent compound. Let's move to the next page. Now these are important for your reasoning questions. Now one thing, if I have seen that a lot of students get confused with this part a lot. So I always say that if in the examination hall they have given you anything for electrovalent compounds and they are asking you that this is happening for electrovalent compounds, give reason for your answer. Remember two important things for electrovalent compounds. The first is very strong electrostatic forces of attraction. The second is the ability to form ions. So if they say, oh, you know what, it has high melting and boiling point, why? That is because they have high electrostatic forces of attraction between the ions. Therefore, they have high melting and boiling point. They can say something like that they do not conduct electricity in the solid state, because in the solid state you do not have ions present, so no conduction of electricity. Then let's say they say dissociation. Okay, so for example, they get dissolved in water. So, or when you dissolve it in water, it breaks into ions. The reason is that when you mix water in it, the electrostatic force of attraction weakens up, and then they break into ions. The electrostatic force of attraction is keeping your ions close to each other, and as soon as that weakens up, they break down into ions, so dissociates into respective ions. So if you think about it, all of the electrovalent compounds will have something up and down around the same lines. That means the ability to form ions and high or strong electrostatic forces of attraction between ions. So everything will work around this. Then if we talk about covalent compounds, majority of covalent compound problem is that they have weak forces of attraction between their molecules. So see this one. Then boiling and melting point, they have low boiling and melting point because weak forces of attraction. Electricity conducting nature, they are non-conductors of electricity because no free ions. Then ionization in solution, on passing electric current, non-polar covalent compounds do not ionize. Some of the covalent compounds are polar in nature. They ionize in their solution. So for example, when we talk about HCl, polar means one of them is attracting the shared pair towards itself. So it has high power. That means negative and positive charges, they can dissociate or they can ionize themselves and can help in the conduction of electricity, but non-polar covalent compounds will not, because no free ions are present. The same thing is happening in dissociation. Then solubility, these are insoluble in water. Why? Because when you even put water in it, there are no ions being dissociated. The solubility, because as organic solvents are non-polar, hence these dissolve in non-polar covalent compounds. Okay. Now rate of reaction, they show slow speed of chemical reactions in aqueous solution. So in covalent compounds, old bonds are broken and new bonds are formed. Thus the reaction is slow between covalent compounds, because one of the covalent compound will break and eventually go forward and make a new covalent compound. So slow process. So that's it here. Alright, so I hope you can go through this entire table thoroughly, even if you have any doubts in any particular point, because I have not gone through a lot of detail here. But all of these points are very important for reasoning questions. Okay, students, just one important thing that I just realized, that a lot of students may get confused with dipole molecule. So when I mentioned dipole molecule and I mentioned two opposite charges are present, I'm not talking about ionic compounds. I'm talking about polar covalent compounds, in which one of them, when it pulls the shared pair towards itself, it gains slightly negative charge, and the other one gains slight positive charge. So such a molecule in which two of the opposite charges are present is a dipole molecule. So I hope that part is clear. I was not talking about ionic compounds. That is, dipole molecule is a molecule which contains slight negative and a slight positive charge within the molecule itself. Okay, so I hope that is clear. So this is it for today's session. I hope this mind mapping video was interesting for you. If you have any doubts and queries about anything in particular, you can reach out to me either on Telegram comment box below, or you can email me on psclassesicse@gmail.com. Thank you so much, students. I hope you have a beautiful day. Stay tuned for more content.